Question number 74 is giving us an example of a linear programming problem, and it's showing us our constraints, and it wants us to draw the graph of the constraints and determine the vertices of the feasible region. So we're going to treat this like any other system of inequalities, and let's go ahead and rewrite these as kind of a slope-intercept form. So it's going to give us 3y less than or equal to, let's do negative 2x plus 12. Divide by both sides by 3. It's going to give us y less than or equal to negative 2/3 x plus 4. So we know that our first intercept is going to be 0, 4. And then let's set this side equal to 0 and solve for the rest. So we've got 2/3 x plus 4, or negative 4 equals negative 2/3 x. X equals negative 4 over 1 times 3, negative 3 over 2. That's going to give us x equals 6. So we've got 6 and 0, for this equation. And then let's do the next one as well. We've got y less than or equal to negative 2x plus 8. So that intercept is going to be 0, 8. And now we want to know the x intercept. So we've got 0 equals negative 2x. We can just skip a step, minus 8, or x equals 4. So now we can draw that. And looking ahead, our biggest number is 8, so let's do this in terms of 8. So let's do 4 and 8 here, 4 and 8 here. We've got 0, 4, so 0, 4 is going to be here, and a 6, 0 is going to be here. So one of our lines is going to go something like this. And then the next one, we've got a 0, 8, and a 4, 0. So that one is going to go something like this. And now we want to look and see, both of these are saying that we want greater than or equal to, less than or equal to. So we're going to keep these solid lines. And we want values that are lower than that. So we're going to end up with these values, but then we also had some other constraints here. We want x values greater than 0. So we want these values, and we want y values greater than 0. So we want these values. So really all we care about is this little section right here. And we want to know what this point is. So you might be able to visualize that, and you might not. I can't quite visualize it. So I'm going to go ahead and figure out what that is. So I'm going to set them equal to each other. So I've got y equals negative 2x plus 8. And then we'll plug that into the other equation, which was, I'll have to find it on here. Right here, sorry. Got a little bit lost there. So we've got negative 2x plus 8 equals negative 2/3 x plus 4. So we'll combine, let's do plus 2x here and minus 4 here. That's going to give us 4 equals 2x. We want this to be in terms of 3, so that's going to be 6/3 x minus 2/3 x. or 4 equals 6, 5, 4, 4/3 x. And now we can multiply by 3/4. So x equals 3. And then we can plug that into the other equation. So if we plug it into here, it's going to give us -6 plus 8, or 2. So our one vertex is at 3, 2, and the other one, if you can see that, is at 0, 0. So draw the graph of the constraints and determine the vertices of the feasible region. So those are your vertices. We've got 0, 8, 4, 0, 3/2, and 0, 0. And then B is asking us to use the vertices to determine the maximum and minimum profit. So here we're going to take our profit equation and we're going to plug in those vertices. So we've got P equals 5, x is 3, plus 3 times y is 2. That's going to give us 15 plus 6 equals 21. So our maximum profit is going to be 21. And our minimum is going to be 1. Both of those equal 0. If you can see, if we plug in 0 for both, we're just going to end up with a profit equal to 0. So that's our minimum. There you go.